Hello, so today we are going to be doing IPv4 subnet masks using IP subnetting method, and in that we are going to be understanding and trying to find out the number of the classes, the number of network subnet host bits, how to represent subnet mask in binary, number of hosts, subnets, octet increment, and finally range of IP subnets. So let us get started having knowledge of what is classful, classless IP addressing and host bits, network bits. So you should have a basic idea of it. I'll just give a brief overview of IP subnetting method. So we will be using these three classes. I know classless IP addressing is what we use these days, but this is what we're going to use to do IP subnetting method. So this the range for class A is 1 to 126. This is 1 to 8 to 191. This is 192 to 223. You may notice that there are two missing IPs 127 and 0. Where are they? So they are basically used in loopback addressing, which is loopback IP addressing, which are IPs reserved for the computer to communicate with itself. As the name suggests, this is just for your information. It is not going to be relevant when we do subnetting. The network bits assigned for A are 8, 16, and 24. Now these are the traditional ones established by classful IP addressing. Now in classless IP addressing, which we use currently, there's something known as CIDR, which has which is classless interdomain routing. It is a newer way of technology which lets us choose any number of bits for the network part. So these are the network bits. So it lets us choose anything we want according to our needs. That is, it gives us more flexibility and it helps us either make the network bigger or smaller based on our needs. So this reduces IP wastage, it minimizes it, so we can use any number of network bits. It could be 26, it could be 27. It's up to us basically. Now having knowledge of this, knowing this is really important. The range is very important as we proceed on to a question, an example. So the IP given to me is 199.17.0.0. The number of networks, let's go traditional this time. First question, 24. And the required host we're supposed to fit while subnetting is 32. So let us figure this out, right? So first we need to find out the class. So first step is class. Which class does this belong to? Always look at the first octet. The first octet is what is going to give you, not the second, not the third, not the fourth, the first one. So 199, where does it lie? 199 lies in this range. So obviously it belongs to class C. The second one is to figuring out the bits for network, subnet and host. I always find it easy to make this table because this table, getting this table right is going to be essential as it is the backbone of this whole subnetting. So we've already been given this, right? 24. So we'll just write that down. See, our table is 1/4 of a table is done. Then here an important step. So the required is 32, right? But the total required, which we'll actually be needing, our actual we're going to be dealing with is not 32, but it's going to be 32 plus 2, which is 34. This is what we're going to be dealing with. Okay. And now to find out the host bits, you will be thinking, if you have studied IPv4 before, you will be thinking, okay, wait, the total number of bits is actually 32 for any IP address. Behind an IP address is a combination of ones and zeros, a binary combination, and it consists of 32 bits. This is standard for IPv4, it won't change. So you will be thinking, okay, 32 minus 24, that leaves us with 8 bits, 8 and 0 or some other thing. No. So this is how we're going to proceed with finding out for host and subnet bits respectively. So basically we're going to find out a power of 2 which is going to be greater than the total required, that is 34. So a power of 2 which is greater than 34, what is it? It's 6. So 64 is greater than 34. You'll think, but oh, 32 is closer to 34 than 64. But no, if we use 32, it will be lesser, and that is not what we need. A total requirement is 34. So we will need something which is bigger than 34 to accommodate 34, right? So it is 64. So our host bits is the power. So we will write 6 here, and using basic maths, 32 minus 30, which is network plus host, that leaves us with 2. So our subnet mask is basically network plus subnets, which is 26. See, this is the basic structure. This is done. Now the rest of the part is very easy. Now to find the number of hosts and the number of subnets, this is the most straightforward part of the question of the example. This is a basic formula, 2 raised to h minus 2, and this is 2 raised to s. So 2 raised to h minus 2. H is 6, so 2 raised to 6 minus 2, which gives us 62. And 2 raised to s. 2 raised to s is 2 raised to 2, which gives us 4. See? Easy. Next. So now this is subnet mask in binary. You might be thinking this is the most toughest one probably. Actually, nothing is tough. Subnet mask in binary, yeah, I know it's a combination of ones and zeros. Is there some sort of algorithm? Is there some formula? So this is the most easiest way. I'm just going to divide this into 4 because, yeah, 4 octets. Each one will have 8 bits because the total is 32. That is the standard. This is the total number of bits for any IPv4 IPv4 IP. So remember, in our table, if you just look back, our table has, I'll not be referring it right now, but if you just look back, you'll get to know subnet mask is 26 and host is 6 because 26 plus 6 again 32. Always ensure that this and you will never mess up. Then you should know that subnet mask, all of it will be considering or consisting of ones, and this will consist of 0 because that is what network and host bits are if you go through your theory. Then 8 plus 8 plus 8, all of these are 24, and just 1 and 2 because subnet masks, all of these are going to be ones. So this will be 26 ones, and you will get 1, 2, 3, 4, 5, 6, 6 zeros. Easy. This is going to be your subnet mask in binary, 26 ones and 6 zeros. Done. Now you're going to find out octet and increment. So this is important for the final, very final step, which is the range of IP subnets. So octet, what does it mean? It means where the last one is present. As simple as that, do not get confused. Where is the last one present? I know there are 24 ones, there are 3 octets full of ones. But here we have our last one standing. So our octet here will be the fourth octet. This part, okay, this slide rather, you do not need to refer to the table as much only for the subnet mask and host. So you will get this. And you will have to find out your increment. What do you mean by increment? So increment is basically how the range of IP subnets, how it increases, the range, how it increases. That is what it is. So increment is the number of, there are 6 zeros. So that is how it is going to be. So 2 raised to 6, which is 64, and that is going to be your increment. Yay, done. Next, you will find out your range of IP subnets. Now for range of IP subnets, I mentioned that you will require octet and increment. So bear that in mind while you're finding it. So the given IP to us was 199.17.0.0, and it ranges to 199.17.0.63. Again, 199.17.0.64 ranges to 199.17.0.127, and so on and so forth. How did I get this? Like I said, just refer to octet and increment. Increment. Why this distance? Because 64. We calculated this. The 64 and fourth octet. That is why it only increases by 64 in the fourth octet. See, you got this. This is it. And you will. This is an observation, not really relevant, but I'll just show you network ID. Okay, this is the network ID. It is even, and here the broadcast ID is odd. See, it's odd. This is even. This is always going to be there, no change. Let us look at another question. 176.12.0.0/16. This is a question, I'm just giving it to you. And the requirement is, say, let's keep 150 hosts. We had kept the same number, 32 hosts and 32 bits, so it might have gotten a little confusing. I've also kept, now let us first find class, the class. This one belongs to, just look at the first octet, go back, you'll see it belongs to class B. Next, we will make our table. NSH subnet mask. Great. Now given to us network bits is 16. Okay. Now here, remember, do not forget our total requirement will be 150 plus 2, which will be 152. Then you will find the power of 2, which is greater than 152. What is the power of 2 greater than 152? Yes, it is 8. So we'll get 8 hosts, and the subnet would be 8, because remember, 32 bits is total, so you just have to subtract. Its basic arithmetic, nothing more. Subnet mask would be 16 plus 8, which gives us 24. There, we're done with our table. Easy. Next part is obviously number of hosts, which is 2 raised to h minus 2, which is basically 2 raised to 8 minus 2, which gives us 254. And number of subnets, which is 2 raised to s, which is 256. See, you're done. Next, next, we need to find the subnet mask in binary. Now you will be like, okay, this is easy. Now you need to understand this is a different one. Okay, this is different. This is a different question. Please pay attention because this might be a little confusing. Great, I divided it 8, 8, 8. Now, if you go back into the table of this question, you will find subnet mask is 24, host bits are host bits are 8, because obviously 24 plus 8, it should give you 32. This is how we're going to represent it. So perfect, right? This is all of this is subnet. This is all is 1, and all of this is 0. So there'll be 1, 2, 3, 4, 5, 6, 7, 8 zeros. Great. This might Now you're going to find the octet. Where do you think this octet one is? What did I say about octet? It is the octet in which the last one is present. So here the last one is present in the third octet. So you're going to write third. What about increment? Where is What is going to be the increment? Increment is the number of, so the increment here is 0, which is basically 1. It means the number of host bits in the third octet. Host bits in the third octet. Where are the host bits? There are no host bits in the third octet. There is no 0 in the third octet. So it will be 2 raised to 0, which is 1. Okay. This is a possibility. Yes, you can clearly see. Next, we're going to find out the range. Okay, the range of these IP subnets. So our question was initially 176.12.0.0. It ranges to 176.12.0.255. Similarly, here it will be 176.12.1.0 to 176.12.1.255. 176.12.2.0. I'm just writing because this question might seem a little confusing, and so on and so forth. Now I think we've got 3. It is understood. Okay, explanation time. We were given the third octet. You can see there is an increase And also the increment was 1. Now I'll just go to the previous question. The previous question, the increment was 64, and we have right now our increment is 1. So you can see it increasing by 1, right? And it is also increasing in the sense, if you have a little, it will be helpful for you to have a little more IPv4, the key features of IPv4, how it is represented, then this question and how it works, the framework of it will be easily understood, right? So I'll be taking the last and final question, the last and final example for it to be extremely clear. So we've tackled C class, we'll tackle B class, let's go for A, right? So our A class would be 110.0.0.0/8 number of network bits, and the total required, and this is going to be fun, total required is 15,000 hosts. Okay, a lot of hosts. I mean, it is pretty obvious because class A in fact represents millions of hosts. So, I mean, that is what it is. So, this is class A. If you look from the table, also you'll understand. Now, let us make a bits table NSH. This is subnet mask. Great. So, number of network bits is 8. What will be the total required? Remember, you're supposed to do 15,000 plus 2, so 15,002. Now, a power of 2 which is greater than 15,002. You will have to find that out. Basically, it's 14. Okay, because 2 raised to 14 is 16384, which is greater than 15002. So, 14. And that leaves us, so 32 minus 88 plus 14, which leaves us with 32 minus 2, 22, which is 10. So the subnet mask here will be 18. See, no matter how big the number is, the logic is going to stay the same. So focus on the logic. That's all. Next, we're going to find number of hosts, which by formula is 2 raised to h minus 2, which is 2 raised to 14 minus 2, which is 16382. And number of subnets, which is 2 raised to s, which is basically 2 raised to 10, which is 1024. Great. Next. Next, we're going to find the subnet mask in binary form. So I'll make my rectangle 88832. Always adds up to 32. Right. So our subnet mask length here was number of network bits basically 18, and host is 14. Always adds up to 32. Remember that. So it'll be here, we'll at least finish 2 octets because 8 plus 8 is 16, and we'll just add 2 more, 18. And the rest of these will be 1, 2, will be zeros, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be our subnet mask in binary format. Now let us find our octet. What octet do you think? Last one is standing in third one, so third. And increment is 2 raised to 6 because number of host bits in the third octet, 6 hosts, 6 bits, 6 zeros, so 2 raised to 6, which is 64. See, you're all done. Next, we're going to find the range. The range would be, so we started off with 110.0.0.0.0, 110, yeah, and this will range to 110.60.63.255. This will continue from 110.0.0.64.0 to 110.0.127, 255, and so on and so forth. Let us verify. So the octet we were told was the third one. You can see it's increasing, and the increment was 64, also visible. See, it's increasing by 64. So you got it. You're done and dusted with the basic IP subnetting method for IPv4. This is all you need. Obviously, there is something which is known as FLSM, and then you've got your dynamic one, which is a variable one, variable VLSM, which I'm not covering here.